Okay. Hey guys, today I'm going to be deriving the differentiation formula. Now we all know that when f of x is equal to x to the power n, and the first differential of f of x is going to be n into x to the power n minus 1. But this is the formula. How is it actually derived? How does this actually work? And that's what I'm going to show you today. So now we all know that when you're differentiating a function, all you're doing is basically you're finding its gradient. Now, what we've learned in, 8th grade is that your gradient is going to be your delta y over delta x. Suppose this is my f of x or x to the power n over here. I'm taking 2 points. This is x and this is x plus h. Can I find the gradient between these 2 points? So here what I'm going to do is I'm going to take x plus h when it will be here. The point's y coordinate is going to be x plus h the whole to the power n, and the point x is y coordinate is going to be x to the power n divided by x plus h minus x. Okay, now something really intuitive what we have to use here is of course binomial theorem. I mean, we all know if we're deriving something for differentiation, you're going to have to use limits, because limits is what comes below differentiation. Limits is what forms the base of differentiation. So now, quite obviously, we need to know that h is approaching 0. Why is this so? Because you're finding the gradient at a point. You're not finding a gradient between this point and this point. You want to find the gradient at a point. So if h here is 0, so then x plus h is the same basically as x. So you're finding the gradient at this point x. So your limit shows that your h is approaching 0. And now here you're going to have to use binomial expansion. So by expanding it, we know that this is going to give nc0 into x to the power n into h to the power 0 plus nc1 into x to the power n minus 1 into h plus blah 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 blah. It's going to keep going on and on and on and on. And I'll show you in a little bit why this doesn't matter till where it goes on. And of course, we're going to copy this down here, minus x to the power n. Now for the denominator, you have x plus h minus x. Just cancel the 2 x's, you're going to have h remaining. This is going to give you limit as h approaches 0 of what? Of x to the power n plus n times x to the power n minus 1 into h plus, I mean, if you want to add a third term for the expansion, you can. So this would be nc2 into x to the power n minus 2 into h square minus x to the power n, because this has to be copied down, divided by h. Now here comes the intuitive slash tricky slash common sense. It's a bit of all part. X to the power n is here, x to the power n is here. Here it's positive, here it's negative. You can just remove them both. So your limit as h approaches 0 of n x to the power n minus 1 into h plus nc2 into x to the power n minus 2 into h square plus blah 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 blah. The entirety divided by h. Sorry. So, okay, anyway. So when we take this out, you can see that h can be cancelled from a lot of places. This is basically removing these limits and removing the h as well. So I'm going to get n into x to the power n minus 1 plus nc2 into x to the power n minus 2 into h, because one h is gone here, so this will become 1 h to the power 1. One h is removed here, so this h will also be removed, plus blah 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 blah. Now h is basically 0, isn't that right? So this 0 does not matter. After this, the h's indice or the h's exponent is just going to increase and increase and increase. 0 to the power whatever is going to be 0, it's always going to be 0. So is equal to n into x to the power n minus 1 plus 0 plus 0 plus 0 dot 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 is equal to n into x to the power n minus 1. And this is your differentiation formula. Thank you.